Hi, everyone. Today, in talking about the chemistry of living things, we are going to take a look at uh, concept 1.2, which has to do with water. Now, the idea of water is very familiar to us. We all drink water, wash our hands. We're familiar with it, but there's some very cool things about water that allow it to perpetuate life on our planet and sustain life on planet Earth. So, in all living things depending on water, it really has to do with the concept of hydrogen bonds in the water. So, we talked about different types of chemical bonds in the last concept 1.1. And in that, we looked at covalent and ionic bonds. And those involve electrons being shared or donated and accepted. But in this case, hydrogen bonding is different. So, hydrogen bonding exists in terms of how the water is structured. So, we know that water is H2O. H2O. Everybody knows that's water. But what does that really mean? The 2 in H2O means there are two hydrogen atoms, and then the O stands for oxygen. And this here I always refer to it as like a little bit of a Mickey Mouse type structure of the water molecule. In that structure, there are little positive charges. See that plus sign there attached to the hydrogen? And see that other plus sign attached to the hydrogen? And then down here, see this negative sign associated with the oxygen? These slightly positive and slightly negative areas allow for water to be classified as what is called a polar molecule. Think about like polar meaning opposite, like the North and South Pole. But in terms of science, polar molecules have these little regions of positive and the little regions of negative. Nonpolar molecules, they don't have those charged regions, and there are nonpolar molecules, but something that makes water so special and gives it its properties is the fact that it does have these slightly positive and slightly negative areas. Please, please, please remember that the hydrogens have the slightly positive areas and the oxygen has the slightly negative area. So, what are these properties that we're talking about that make water so special? Well, there are three things, and they're all going to be kind of like weird sciencey type words, but I'm going to explain them to you so they hopefully make sense. The first property of water that makes it super helpful and responsible for allowing life is this idea of high specific heat. Well, that probably means nothing to you, and that's okay. Specific heat and high specific heat means it doesn't want to change temperature. Water doesn't want to get hot. It doesn't want to get cold. It doesn't want to freeze. It doesn't want to boil. And that is evidenced by if you've ever tried to boil a pot of water, it doesn't just happen like that. It takes a little bit of time on the stove to heat up the water. Why is that important for living things? Well, inside of your body and really the bodies of most living things, there's water. So if it's really hot outside, the water inside the living thing's body doesn't want to change temperature. So it kind of keeps it maintaining a stable temperature inside. Same thing in really, really cold temperatures. The water doesn't want to freeze. It resists that change, and that allows living things to that are filled with water in some capacity to resist that change in temperature. So it's very interesting. That's how like fish are also able to kind of be adapted in wintertime to live in the water underneath that frozen layer. And that's one of the, a cool property of water as well. So first thing that we're talking about here, so high specific heat, hydrogen bonding is responsible for that high specific heat. So these hydrogen bonds form between slightly negative areas and slightly positive areas within water. The next thing that we're going to talk about is cohesion and adhesion. And that's really what we're going to focus on in our study of water and its kind of unique properties. Cohesion is when water is attracted to essentially itself. Okay, so think about water being attracted to other water molecules. And adhesion is when water sticks to something other than water. So hydrogen bonding, for lack of a better way to describe it, is stickiness between the molecules of water. So itty bitty, teeny tiny little molecules of water are sticky. And cohesion is when the water sticks to itself, essentially sticks to other water. And adhesion is when water sticks to something other than water. So if this is all like a little bit abstract right now, I'm going to show you a picture. And this should be, if you go out if you have a yard or, see any grass, especially in these mornings and especially in like September, the fall, there's kind of a little bit of dew on the blades of grass, or if it's just rained. And if we look at these blades of grass here, we see kind of water collected in little beads on top of the blades of grass. Within this bead of water, so all this here is water. Within this water drop, there are tons of individual water molecules. And all those tons of little water molecules are sticking together. And they kind of form a little like curvature of water on the surface of the blade of grass. Something else I want to point out, FYI, that is cohesion, when that water sticks within the water droplet itself. And then if we look at the water droplet sticking to the surface of the grass, that is adhesion. So the water droplet is stuck and formed on the surface. And where it sticks on the surface of the grass, that is called adhesion. So in summary, hydrogen bonding is caused by the fact that water is a polar molecule. And in being a polar molecule, there are little areas of positive within the water molecule and little areas of negative. We know that opposites attract. So when you have a bunch of water molecules together, the little positive areas are attracted to the little negative areas on another water molecule. That idea is called cohesion. It's stickiness between one water molecule, and another water molecule. Similarly, there is adhesion, which is stickiness between water molecules and something else. And then in this example here, think of the surface of a blade of grass. And that's really all there is right now about water. there's another little drawing that I'm going to want you to take a look at in the future. Thank you.